Okay, so hi there, everyone. Greetings. I am Chard here, and I will be presenting my paper in working on work problems. Let me give you an overview. First, we're going to talk about the abstract, the introduction, the known results, the main results, and then the conclusion of the paper. So let's start with the abstract, and then, of course, the references. Forgot to mention that. The abstract tells us this is about Vedic mathematics. So when working on fractions, one can use the Vedic Sutra, transpose, and apply to solve faster and with much ease. From here, one can extend the application of the sutra in fractions and use it in problems involved in the real world. One of those problems are work problems. That is, if person one can do the work in time t sub one and person two can do the work in time t sub two, then how long will it take? How long will it take if they work together, denoted by big T? Work problems are very common in any types of examinations, especially in the licensure examination and the general education questions. This is because of its wide applications in real life. Using the Vedic method, we can answer these kinds of questions very rapidly, and this paper shows the firepower of the sutra transpose and apply on work problems. As we go along and when we arrive the generalization, the sutras by elimination and retention and the sum of the products will be aiding us. Now let's get into the introduction part. One of the most important lessons in algebra, particularly in rational equations, are its applications, of course. And one of the best applications of rational equations are work problems. This is a direct real-life application of finding x in rational equations. And with the Sutra Parvayat Yavayat, transpose and apply in English, presented to us by Sri Bharati Krishni Tirthaji, all the work and work problems will be answered efficiently. Well, first we will present the known results, which is very a routine work in mathematics. Rational equations, let's define it. Rational equations are equalities consisting of at least one rational expression. A rational expression is a ratio in the form of P over Q, where P and Q are polynomials, and Q must not be equal to zero. In solving rational equations, the general way or the routine way is to first find the least common multiples of the denominators, also called the LCD, or the least common denominator. Number two, multiply both sides of the equation using the multiplication property of equality, so to get rid of the denominators we have. And then we will be isolating the x. We will simplify the equation and use algebraic manipulation to get the value of x. By the known results, it's very straightforward and everyone knows how to do this. This is very important as far as working on work problems wherein two of them work together. But before we get into the main results, we should have these remarks that everyone should understand, and we should have these assumptions. Number one, the size of the rooms or the size of any work that they have. It's very common about the rooms problem when you see it in questions. It's even most of them are painting of the rooms. They work together in a certain factory or such, or any work to be done. It should be identical, and the work exactly at the same. They work exactly the same pace for all persons. So when they work together and then when they work alone, so it should be at the same pace. Those are our assumptions. The main results are now making use of Vedic techniques or Vedic methods. So we're not good. If you're going to remember, we have three steps in the routine job. In the Vedic method one, using the sutra transpose and apply, one simply does the following steps to obtain the total time given total time big T, given the times of the two persons. So in the known results, we need to isolate X. We need to have algebra and those sort of things. So if you are a student which looks algebra as a little bit painful in the mind, so you will really have a lot of time to work on that. But making use of this Vedic method, we will have two simple steps. Since we have two persons, times of two persons, what you will do is multiply both numbers and set it as your numerator, and then add both numbers and set it as your denominator. So we'll have this general formula if you want the formula. Um, this will be it. So your big T or your total time will be equal to T sub 1 times T sub 2, or T1, T2, I'll call it right now, all over T1 plus T2. That will be our formula for getting the total time, which is very straightforward. And you don't need really much algebraic manipulation here. You just need to get the numbers and then multiply and add them and then set them as fractions. Another questions mostly that is coming out from work problems is that if you're asked to obtain the time of one person, it's either T sub 1 or T sub 2, given the total time, big T, and the time of another person. So we follow the steps. So we also follow two um, very minor steps. Number one, multiply both numbers and set it as a numerator. That's just the product. And number two, subtract the bigger number by the smaller number and set it as the denominator. So the bigger number will always be the other time, the other person's time. Their total time will always be lesser than their time together, because notice that if you have a big T, your time together, it will always be smaller because they are helping each other. So the formula will be, if ever T sub 2 will be the one which is we need to find. So the numerator will be T sub 1 multiplied by big T all over T sub 1 minus big T. So that's our main results for Vedic method, Vedic method 1, Vedic method 2. Of course, in mathematics paper, we need to present the proofs. Though in Vedic maths, it's not that important about the proofs, but we really need to present it in a paper. So Vedic method 1, remember this. How do we obtain the total time big T? So given this, so let's present the proof. Let T sub 1 be person A's time, T sub 2 be person B's time, and big T to be the time when both persons work together. So our general formula for the work problem is going to be like this: 1 over T sub 1 plus 1 over T sub 2 is equal to 1 over big T. What we want to do is to get the LCD first. Getting their LCD, which is T sub 1, T sub 2, big T. Multiply the GCD and distributed to all of the fractions. So some denominators will be canceled. So in the first term, we have T sub 2 big T plus T sub 1 big T equals T sub 1 T sub 2. And then we're going to isolate the big T to get, since we want to get the value of big T, so we want to isolate it. So we have big T times by factoring T sub 1 plus T sub 2 is equal to T sub 1 T sub 2. So isolating big T, we will need to divide the whole equation by T sub 1 T sub 2, T sub 1 plus T sub 2. So what we have is big T is equal to T sub 1 T sub 2 time all over T sub 1 plus T sub 2. And that's the end of the proof for Vedic method 1. So that's how we end up with our Vedic method 1. For Vedic method 2, let's provide a proof as well, since it's important. So remember, if we have a missing time T sub 2, so we have this formula T sub 1 times big T all over T sub 1 minus big T. So to present the proof, again, we have let T sub 1 be person A's time, T sub 2 be person B's time, and big T to be the time when both of them work together. So again, we have this general formula. We will be getting the LCD, same old, and then we will be distributing the LCDs. And what we want to do is we want to find T sub 2. So T sub 2 is right here and right here. So what we want to do is to isolate all T sub 2s on one side of the equation. So we're going to transpose this one here into the other side. So we have, it's going to become minus T sub 2 big T equals, we're going to factor out the T sub 2. So notice on our right side, we have T sub 2, which is factored out, multiplied by this. And then we would want to isolate T sub 2 as a whole. So we have T sub 1 big T all over T sub 1 minus big T. So that's where we get our formula, and that's the end of the proof. In most of the problems, in work problems, it's not always going to be 2 persons alone. There are problems which gives us n persons, or 3 persons, or 4 persons. So let's generalize it into n persons. So my paper works beyond the 2 person, which is the common one, which everyone believes to be the common one. I would like to generalize it to n persons, wherein, say, if we have n persons, how can we get the time if they work together, and the time if a certain person, a certain person's time is missing. So to generalize this, I will call this Vedic method 3. By additional sutras, by elimination and retention, and the sum of the products, to obtain the total time big T given the times of all n persons, we have this general formula. We have big T is equal to the product of all T sub i's, where I is running from 1 to n, all over the sum of all the products of T sub minus I for all minus I for all I running from 1 to n. So that's our formula for Vedic method 3, which I will give a proof in a little bit. For our Vedic method 4, so say we're going to ask, there's some certain person T sub I, that's a time of 1 person, which is inclusively between T sub 1 and T sub n. Given the times of n persons and given their total time, big T, we have this formula. So to get the time of some T sub I, or the time of some person, is equal to T star sub minus I all over T sub minus I minus the sum of all T star sub minus I and I for all I running from 1 to n. So that's our general formula, though it's a handful, It's a big formula to deal with. But again, I want to emphasize that the purpose of the formulas is to provide the proofs. But in Vedic methods, it's very going to be straightforward. In and you don't need to really um, memorize the formula, but the algorithm, just shows you how the algorithm works and the process works. So let's prove Vedic method 3 first. So for Vedic method 3, remember that this is our Vedic method 3, wherein we have T, big T. We want to prove this. So we have big T is equal to the product of T sub I, all I running from 1 to n, and all over the sum of the products of T sub minus I for all minus i's for all i's 1 running from 1 to n. So let T sub I be the person A's time, let T sub 2 be person B's time, let T sub 3 be person C's time, and so on until we have T sub n be person N's time. Let big T be the time of all these persons working together. So we have this. It's not only going to be 2 persons, but it's going to be n persons up until we will end with T sub n. We will get the LCD, which is T sub 1 times T sub 2 times T sub 3 times until T sub n times big T. So we have that LCD. And then afterwards, we will multiply that LCD to each of these terms here. So what we have is going to be, we're going to missing a single term. So for example, on the first term, we're going to missing T sub 1 because it's canceled out. On the second term, we're going to be missing T sub 2 because it's canceled out, and then so on until we'll be missing T sub n. And then on the other side, we will be missing T sub big T rather, because it's going to be canceled. So with this, what we will do, notice on the left side, we have all the big T's here. What we're going to do is we're going to pick all the big T's from each of these terms and factor it out. So after picking, we have big T now isolated on as a factor of all of these terms on the left side of the equation. Let the right side as it is. Let's continue this on the next slide. So the continuation of the proof follows here. So this was our last line. What we want to do then is to isolate the big T, since we want to get the value of big T. We have big T is going to be equal to the products of all T sub 1, T sub 2 up until T sub n all over the products of T sub 2, T sub 3 up until T sub n plus, meaning in this term, we're missing T sub 1. In this term, it's going to be the product except T sub 2. Next term, it's going to be the product of all times except T sub 3, and then so on until we have all of the products of T's except T sub n. Then we're going to sum them all. So this is the general formula actually, but notice it's an ISOR. So let's use some mathematical notations to simplify this product. So we have big T is equal to the product of, or the product of T sub i's for all I running from 1 to n, and the sum for all I running from 1 to n of the products for all minus I of all T sub minus I. So where T sub minus I is not actually a negative sign, but it's an indication that we are missing a certain I. Okay, not a negative sign. Okay, so that's the proof of Vedic method 3. Let's provide the proof of Vedic method 4, which actually took me some time to prove on paper. So Vedic method 4 is about when we have a missing T sub I, where T sub I is within exclusively from T sub 1 to T sub n. And this is again the formula. So T star sub minus I all over T sub minus I minus the sum of all T star sub minus I and I for all I running from 1 to n. So let it be T sub 1 be person A's time, T sub 2 be person B's time, T sub 3 be person C's time until T sub n be person N's time. And let big T be the time of all persons working together, and let T sub I be someone's missing time. So wherein T sub I is inclusively between T sub 1 to T sub n. So we have this. We try now to emphasize that we have a certain T sub I which is within T sub 1, T sub 2, T sub n. So we just need to pick that certain T sub I, and then that person I's time is missing, and we want to get that, and which is within the string of within the series here. So what we're gonna do is again commonly get the LCD, and then we have T sub 1, T sub 2, T sub 3 up until we reach T sub I along the way, and then T sub n times big T, and then we will try to distribute that. And I think we need the next page. It will not fit here. Okay, so this was our last line wherein we have the LCD already taken here. So what we want to do is we want to distribute the LCD in each of the terms. So when we do that, we will be missing a certain term. So for example, in the first term, we'll be missing t sub 1 because it will be canceled out. So notice in the first term here, t sub 1 is missing. In the second term, t sub 2 will be missing because we canceled that out here. We multiplied it by t sub I. So meaning, notice we are missing t sub I here. We only have the forms or the terms t sub minus 1 and t plus 1. So meaning t sub I or t sub I minus 1 and t sub I plus 1. So we're missing t sub I here because it's canceled. And then you know the rest, canceling some parts. Next is we have this. What we want to do is we want to isolate all the terms with the t sub I because we want to get the value of t sub I. So notice that all terms are now transposed to the left side except this one wherein it doesn't have a t sub I, where t sub I is cancelled. So leave it be on the left side and then transpose all the others with the t sub I on the right side. After doing that, we want to isolate the t sub I and all of the terms containing the t sub I. So notice it's going to be a long equation. So the left-hand side is just as is, while we factored out the t sub I on all the terms, including it in the right-hand side. Next part will be we want to isolate t sub I. So t sub I now is equal to the left side, which is t sub 1, t sub 2, t sub 3, up until all the terms except t sub I itself, all over all the terms, missing t sub I and missing a certain number as well. Or rather, in the denominator, rather, we have a term which is missing only t sub I, okay, and big T, minus, after that, the next succeeding terms after that will be missing t sub I and a certain T. So here we have a certain t sub 1 missing and t sub I. Here we have a missing t sub 2 and t sub I. Here we have until we will have all the missing t sub n and t sub I. But notice on the progression we have big T's, except for the first term, which doesn't have a big T. So we can even simplify this, and we will group this all terms after the first term in the denominator to be all the minus, and then they will be added up, and then so that we can isolate the minus sign, because notice that it's all going to be minus signs here. So this is actually the last part of the proof. But what we want to do is we want to, this looks like very an eyesore. So we want to simplify this into making use of some notations. So I made up some notation so that we can clearly write this up. Here in the numerator, I called it t star sub minus I, wherein it's only missing a t sub I here, but it has a big T as part of its factors to get the product. In the denominator, I call it t sub minus I all over here because we're only missing a t sub I, or only a certain t sub I. Minus the sum, notice we're adding them, so we have the minus sign outside the summation notation. Sum of all t star sub minus I, because we're missing a t sub minus I, just like above, and we're also missing a certain T, where this I here, this second I, after the end symbol, will be running from 1 to n. Again, this minus I is a certain variable itself. It's not going to be a negative I, but it's a certain minus I wherein I is missing. So that's going to be my notations, and that's the end of proof. Okay, so again, at least we reached the proofs of this equations, and let me end this with this parts remark. Like I mentioned a while ago, one doesn't really need to memorize these formulas seen above for Vedic mathematics. Focus on the mental calculations, one such with integration and work in the mind. These formulas only work as a guide as far as the paper is concerned, or as far as research papers are concerned, or one can say as a proof of the algorithm or the process, of why the algorithm or the process works. So let's have this conclusion. Vedic mathematics and the Vedic system proves to be very efficient and powerful tool in mathematics, especially in arithmetic and in algebra. We have seen here the firepower of just 3 sutras in applying it in work problems, which can be done in a very easy and fast way. That is as simple as two steps. And we have generalized it in cases where there are n persons doing the work and finding the total time of all of them, and some person's time missing t sub I. Vedic mathematics has indeed reached many audiences to see its beauty and crafts, and I hope it will reach even more until it will eventually be a paradigm shift in mathematics education, so that pupils will have a more holistic approach in mathematics. And I say thank you very much for listening to my talk. I hope you learned something from this paper, though it's focusing on purely proofs and pure mathematics, but I hope you see the light of it. So thank you very much.